Now, let's move on to the number 2, which is the integral of 1 plus x raised to 3 raised to negative 1/2 dx from 2 to infinite. So now, as we can notice, it has an infinite limits wherein we can say that it is an improper integral. And in order to solve this, we will use the limits in order to solve this integral. So now we will first integrate the 1 plus x raised to 3 raised to negative 1/2 dx. So we let this, or we will use substitution, and we let u is equal to 1 plus x raised to 3, du is equal to 3x squared dx, and dx is equal to du all over 3x squared. So substituting this, now we will now have the equation, the integral of u raised to negative 1/2 du all over 3x squared from 2 to infinite. And now we will now move out the constant term, which is the 1 all over 3x squared, away from the integral, and have the equation 1 all over 3x squared integral of u raised to negative 1/2 du from 2 to infinite. So now the integral of u raised to negative 1/2 du, if we integrate it, we will have now the answer 2 square root of u, or 2 times u raised to 1/2. Plotting now the answers, or we will now have the equation 1 all over 3x squared times 2 raised to u times 2 raised to u raised to 1/2, or 2 square root of u. Substituting u, we will now have the equation 2 times 1 plus x raised to 3 raised to 1/2 all over 3x squared. So we are now done integrating this equation, and now we will use limits in order to solve its integral. Limitation of 2 times 1 plus x raised to 3 1 all over raised to 1/2 all over 3x squared as x approaches infinite, minus limitation of 2 times 1 plus x raised to 3 raised to 1/2 all over 3x squared as x approaches 2. We can now solve the limitation of an infinite. As we can notice, the denominator has larger exponent than numerator, so it can be simply 0. Minus, substituting 2x, we will now have the answer 1/2. So 0 minus 1/2 is simply negative 1/2. So this is now the answer, and the problem is a finite integral and it converges.